Today's video is all about frameworks and building out your own API. Now, this is a topic that's been done quite a bit on the internet in different forms and fashions, but what I want to talk about today is specifically all about Apigility. Now, I got to give some credit over to the Zen Framework team for introducing me to a lot of API design and whatnot, and I even saw somebody sign up on my really old Udemy course on Apigility, which frankly, it's a framework that's like super out of date, so I don't know why you did that, but Udemy gave me, I guess, like some cash for that. So cool. Congratulations. You're supporting something super old and legacy. So I guess I could say that this video is for you, whoever it is out there that is supporting something super old and legacy. And what I've learned over the years is that if you're going to create an API, the best framework and language to do that in is Java, and that is using Spring Boot. All right, so let's just do this real quick here. So we're going to throw this under com.smb devop right here, and then we are going to launch this. I'm going to call this a Spring Boot demo. All right, so this word right here, we're going to use Java 7. Actually, we'll use Java 20 here, latest and greatest, LTS. We're going to use Maven. It's old school, but it does the job, and I'm going to use the Spring initializer. Now, if you don't have IntelliJ Ultimate, no big deal. You can also go to start.spring.io, click all of these things, and then you can go through and add some dependencies. All right, but I'm going to do it in this interface just because that's what I tend to do. So let's talk about some tools that are helpful and make things fast. Now, I'm going to just start going down the list here, and I'll just provide some commentary on these. So Lombok, if you have ever written getters and setters in your PHP code, then you'll want to be using Lombok. Lombok makes that really easy. You can just add annotations to classes. And that's a kind of a weird Java term that you might not be all that familiar with, but I'll get into that in a minute here. So I'm just going to pick Lombok. It makes things, especially demos on the web, a little bit quicker. If you're like a super purist, you'll probably avoid that and click the generate getters and setters in your code, or better yet, you'll decide that you don't really need getters most of the time. Okay, now then the next question you need to decide is your project going to be reactive or is it going to be non-reactive? And for the sake of simplicity and 99% of requests out there, we're going to click non-reactive, because reactive is frankly a more confusing programming model. Yes, you can get higher levels of concurrency. Don't get me wrong, you totally can, but you don't necessarily need that complexity. And if you're coming from a thread per request model of the world, let's stick within the same concept so you're not having to learn so much stuff right off the bat. Okay, then you need to figure out whether or not you want to support sessions. Now, if you're doing API only stuff, you don't need sessions. That's generally stateless. But if you're doing a website where you have like a web application and want to log in, then you might want a Spring session in there. Okay, let's go down here. Now, if you're doing a website, then of course you're going to need some form of templating. So that means like you're going to have like HTML templates that are interpolated with variables. You're going to pick Timeleaf in there. And that gives you a base built-in framework. Now, this is something that's like really totally underemphasized in the PHP world, and that is that of security. So this is a massive monster of a topic, but Spring security. And you know what? We just need to go to the website here. Let's go, and I'm just going to Google Spring security. And what we're going to do is you need a run through of this, because honestly, it is like there is so much that is covered inside of Spring security that if you're coming from the PHP world, your mind is going to be blown. Okay, so let's, I kind of just want to, they've got this servlet application diagram. I got to find it here because what I think you need to understand with it is this, I think it is in here, the architecture. Yeah, okay. So Spring security is all based on this whole concept of filters that operate in a chain going down. And if you are working on a security project, what the important thing to know is that Spring security has solved so many of the complexities when it comes to doing security, and you have a ton of flexibility to configure things in your actual application. So if you're getting started and you want to really dive deep into security for any kind of web application, I would personally consider Spring Security absolute best practice on the internet to understand. There's so much you can do too. I mean, if you want to roll your own authorization server, if you want to be like an OAuth 2 provider, you can certainly spend months doing that and building that off of the Spring Authorization Server product. Open source, totally free. If you need to support OAuth 2 login, so if you want to create an application where you have like a sign in with Google type of deal, you can do that with the Spring Security OAuth 2 side of things. And then again, like for the servlet based, that's thread per request, or reactive, which is, I'll call that glorified event looping with magic wrapped around promises to give you a really nice and clean way of describing your request in the sense of a mono, which returns 0 or 1, or a flex, which returns 0 to infinity, things along with subscribers and publishers all wrapped into one like stream of information. So like you always assume an error is a possible flow in a stream. Works really good for certain applications, but other applications it's a real pain to wrap your head around. But if you need a high degree of concurrency, yeah, sure, go reactive. You can do that. Knock your heart out. You'll spend months learning it. And with the new virtual thread stuff coming out in Java, I think honestly a lot of the reactive stuff is probably not going to be as needed. Okay, let's talk about database connectivity, because if you're building an application and if it's going to serve any real purpose in the world, you're going to need to store information. And if you're going to do that, there's really kind of two main flavors from a database-driven standpoint, and that is JPA. So if you're coming from a PHP world, that is Spring Data JPA lays on top of Hibernate, which is most akin to Doctrine ORM. So this takes the whole object relational mapping concepts defined heavily in POVAA, the book, if I recall correctly, and then the whole domain-driven design community. Now, what's a little bit awkward about JPA is that when you have really big entities, and this is true of Hibernate too, is that you can get this like, it's magic secret sauce that just makes database access really quick when you're like traversing tables and stuff, but it can bog down in really complex applications, just like any highly relational data structure can be. So that's where then JDBC came in, and Spring Data JDBC and R2DBC is a little bit lower level, but it's a little bit closer, I would say, to pure domain-driven design, in the sense that you are working with an entity that you save and then it'll rewrite things. Now, that's all well and good. So you got to make a decision between one of these three flavors. Really, it's two camps and then the reactive version of JDBC. Or if you can avoid it, maybe you're going to be storing things instead of a SQL format, then you might be going more with a NoSQL flavor of things. So maybe you're using like Redis. That's always a good starting point for a lot of applications, even if it's just for caching. But if you can sort things out that way, or maybe you like the whole JSON document structure, maybe you're going more the MongoDB or something along those lines. But back to the MySQL side of things, you do need to make a decision about how you're going to handle database migrations. Now, I've used Flyway before. I'm pretty happy with it. The free version works pretty good. Their enterprise paid version gives you some capabilities that already exist in the PHP realm, like the ability to do rollbacks and some other stuff. So I guess just heads up that the features are a little bit lighter in the Java ecosystem for Flyway versus some of the other PHP language equivalent of that database migration management. I haven't used Liquidbase before, so I should probably look into that, but it's just not a tool that I've used on any of my projects. And then this is really where like things start getting interesting in terms of like the capabilities of Spring. So if you need to integrate with and manage workers, there is a lot of ways to do that. So RabbitMQ, message brokering. You can also do Apache Kafka, as well as other mechanisms. Different ActiveMQ is another message brokering mechanism. But at the end of the day, Spring integration, this again pulls in the enterprise integration patterns. These are concepts in the POVAA book that you can use there. Okay. And then Spring batches, if you're doing like big batch operations. So these are non-real-time. So you could think like processing payroll once every 15 days or something like that, right? Like a job that is absolutely gargantuan by design. You need to have state known in and out, and it runs at a frequency. you got that going in there. So that might be what that looks like. Okay, so for the sake of this, though, I'm just going to pick Flyway. Actually, you know what? We're going to skip the whole database thing. That's honestly just that's like a whole sequence of videos in and of itself. And then, so we're going to skip that for now. Spring validation, super handy. Java Mail Sender, that's being able to send email. So hooking up to like an Amazon SES or an SMTP server or whatever, that's the Java Mail Sender if you want to configure that. Ops. Okay, so this is super cool. So if you're launching a microservice, knowing whether or not it is healthy, super helpful. So that's pretty cool. And then also there are all kinds of other things that you can expose. So if you want to collect metrics about your applications, just see how it's running, how much memory it's using, things like that, you can certainly plug in some observability. If you have application performance monitoring, you want to be able to see like what requests are running slower on a given route, New Relic, boom, click that in. Now, of course, that already exists in the PHP ecosystem. Prometheus, I'd say, is very much lacking. And then if you have a complex microservice world, distributed tracing. So you might have a request that flows in from an API gateway, and then it hits your service, and then your service talks to another service. You can have these trace IDs passed through all the way through, and then be able to correlate that in a tool that supports distributed tracing like Zipkin. So that's what that looks like. And of course, unit testing. Now, if you're coming from the PHP realm of things, you might be thinking PHP unit. And that's kind of like, that's built in to everything when we start out. However, if you are doing something that's not as well built out in the PHP realm, is the whole realm of documented API REST documentation. So based on your actual unit tests, you can do Spring REST docs. Now, if you need to interact with ephemeral databases, ephemeral meaning that they disappear and they're launched with your tests, you can launch test containers, and then you can say spin up a MySQL database and then have your repository tests for JDBC validate that you can say insert into the database table. You can fetch things from the database table. You can run your queries. You can just validate that whole integration between your app and a mock database, if you will, but except it's a real running database, just a light version of the thing. So you can do that as well. Contract verifier. This goes way beyond kind of what your typical PHP world is, but if you need to have contracts for your API and client code, then you might want to be using the Spring Cloud verifier. Okay. This is like a whole bunch of stuff in here that I've gone through. Like this is like kind of like the typical decision making you're going to need to do. But the nice thing about this is in comparison to what I've observed in the PHP ecosystem is that these decisions are already made for you, and each one of these projects is very well documented. Like you're not competing for 50 different versions. Like these all work, and they all work out of the hood with just, a few clicks in there. And you can build applications and test certain segments of an application with really good best practices, high quality code under the hood that you don't really question the quality of it. And you're not having to deal with like major language update problems as much as I've observed with composer-based dependencies in that world. So that's kind of a good starting point. So what have we included so far? We're going to get rid of New Relic. I'm not going to do that. I will keep Prometheus. Spring Validation's cool. We're going to skip all the database stuff. I'm actually going to remove Spring Security just because that's kind of a bit of complexity. And we'll just create a simple application with just these dependencies. Okay, now to the meat of this whole thing. That was a lot of talking just kind of about this. But check this out. Your built-in README already has all kinds of documentation. If you're curious how this goes, go ahead and click on the link and check that out. All of these have the basic, elements. You want to know how Spring Actuator works, boom, bam, off to the races. At the end of the day, you can start this thing up. Well, we'll click Enable Annotation Processing in my IDE. That just makes it happy. And I now have a service. So this is Tomcat. That's the web application server running. And it's exposing port 8080 locally. And we can just run that. And hey, look at this. Oh, isn't that so lovely? We have a white label error page. Well, actually, it's a pretty good one, 404. And that seems kind of obvious. We haven't defined a route for it. So in a typical Java project, you're going to have your root thing, and you're going to go into source main Java, and then your reverse DNS namespace. I'm calling this Spring Boot demo. And they have a Spring Boot application. And like every good Java application, it starts with PSVM. That's your public static void main, takes in string, array of string arguments. And then in this case here, we're saying Spring Boot application run. And then it gets this annotation. And an annotation in Java is probably an unfamiliar thing for a lot of PHP devs, but basically if you have done Doctrine ORM type of stuff, it's like that, except it's more powerful than that in the sense that there's actually, it defines an interface, and then those interfaces can do even more things. And those can point to other elements here. So like component scans, enable auto configuration. It's, there's all kinds of components that you can dive into, and they can do certain behavior. Now I'm going to click download sources here, which gives us then all of our documentation for what a given annotation happens to do. And then there can be implementations of those annotations. Okay, back to what we're doing. So a typical Spring Boot application demo is structured where someone says, hey, I'm going to build this thing, and then I'm going to nest a class in there, but let's not do that. Let's be a little bit cleaner. So we'll just do controller. And in this case here, we might even have like, we might have like a API controller, something like that, whatever. And then we're just going to call this people controller. How about, actually, we'll just call this index controller. We'll start there first. And then if we are creating an API endpoint, we'd call this REST controller. This hints to the Spring framework that it should be doing like API structured request marshaling. So you're thinking like JSON or XML back and forth. JSON by default. But again, the framework provides all of that content type negotiation. So rather than having to think about the media types going back and forth, and like in PHP realm, sure, you could do that whole like onion controller, or the onion of components. You might build a special component that does your request response marshaling and all that, or you might have like a Laravel that kind of has a layer that does that, or you might have to specify that in your controller. It's not the controller's responsibility. That's a framework responsibility to do marshaling. You should be able to override that, but it's not the responsibility of that. And then we can do at request mapping. And what that does here is now we can just provide a path right here. So request mapping, and I can just say, let's hear. If we want to say the path is that's our starting path. And there's other options as well. I'm going to just do a control space here. And then these are like various things that this annotation supports. We don't need anything else in there at the moment. And we're just creating our basic endpoint here, public string, and we're just going to call this index action, something like that. And this endpoint is a get mapping, and we don't really need to throw anything else in there. We can be really explicit because we like to do that. And this get mapping right here, and we can just say return index. Okay, now that's odd. Why would we return just index? Well, in here we can now create an HTML file. We're just going to call it index.html. And it works. All right, that's our index. And Spring auto wires up that whole index controller and whatnot. Now, a little difference between PHP and Java land is that you're going to notice you do have to frequently restart because you need to recompile your application. And so there we go. It's recompiled. And that's because it's type safe language. It's not all there. So we refresh this, and there we go. There's our index page, but it's not saying it works. Why is it not saying it works? Oh, because I called this one the REST controller. REST controller is returning the string index. So that's that. Let's turn this into a web controller. All right. So far, so good. We'll optimize that to remove that import. So now we have the new controller annotation stereotype up there. And is it rebooted? It is. Should be rebooted by the time we do that. And there we go. We are now with our It Works HTML template. So there we go. We've got our a REST version and an HTML version right there. So that's like a quick introduction to that. Now, Apigility, of course, provided Versioning, that's pretty cool, right? You can do versioning. Well, guess what? You can do that here too. V1. Wow, that was hard. We're going to do that, and we're going to call this people controller, something like that. Go in here. Okay, there's a REST endpoint. Okay, and we're going to add request mapping, and we're going to say, again, path starts with people. Okay, sounds good. Now, oh, you know what we should do here? We could also do, let's prefix that with v1 people, right? Because we want to do versioning at the path level. Not my favorite approach, but you know what? That's what people do when they're versioning things. But by and large, honestly, like API versioning, you shouldn't really be changing your API versions that much to begin with. Maybe spend a little bit more time planning out what your thing's going to do than how much time I'm planning spinning this up. So, okay, let's, we should be responsible, right? Every good project has got a model, right? Got a model, and we're going to follow the correct naming convention. It's not uppercase, it's lowercase for the paths, uppercase for the actual thing. So we're going to call this a person. What does a person do? All right, now we're getting into the Lombok side of things. A Lombok, all right, data gives you getters and setters for all of your fields. That's like super easy, okay? Private, string, what do they get? How about a first name? Okay, private, string, last name. Now, could I make these public? Sure, I could do that. I don't want to do that. And that's okay. So now what we're going to do is our people controller, the home, normally you'd return a collection. So, okay, we're going to return a list of person. And this is going to be maybe this is our collection. You want to call this a collection action? Sure, why not? That's going to return them all. Okay. Now, because we're skipping the whole having a database thing, we're going to say return list of and then new person. And interesting. Okay. So what we need to do? This person's kind of uninitialized, right? With these values. So let's add an all arguments constructor. You know what that does? That means we now have to initialize it with these things here. This is now invalid. Cool. Thanks. Annotation. So first field is going to be Bob. Last name, Jones. There we go. Random name we got right there. Let's refresh this, reload this whole endpoint. And now we have our basic REST API endpoint. So far, so good. Let's go to people. Boom. What's our problem? We need a mapping. There we go. We now have a get mapping on here. Now, if we're going to create a new person, then we would do maybe like a post mapping. Let's see here. Did I do that? Oh, V1. That's right. We versioned it. We didn't. There we go. There we go, people. API right there. You now have an API. What else do I got to say? Oh, right. You want to be able to, of course we got to post, right? Okay, we want to post to people. Okay, that's fine. We can do that. Private list person. All right. People list. Want to do that? Like that. All right. We'll initialize our empty list. So far, so good. Should we construct this? How do we want to do this? I think this is fine. You know what? We're going to return people list. Return, and we're going to be explicit. We'll follow that. Okay. Post mapping. There we go. And this is going to also return our list of people. There we go. Post action. What does it take? This takes a person. We'll say this dot people list dot add person. Return this dot people list. Okay. We're skipping all the database stuff here, but starting out this time, it will not post anything, or it will return an empty list, right? Empty list. That's what we expect. Now we got to be a little bit fancy here. We need to post to this curl dash. We'll go dash is it X post. Is that right? Is that for the method? I always blank on this. Oh, let's look this up. I'm totally blanking on this. Curl post It's JSON. Oh, I know, at least while we're doing that, header. All right, something like that, I want to say. How to post in JSON. Let's look this up. -x post. Yep, I was right on there. -h. That's our header. -d. Cool. -d. All right. Let's post our person. Gotta escape it. It's because we got quotes and quotes. I could use single quotes. Should we use single quotes? We can do that. Yeah, we'll escape it. First name. Escape that. Fred. Are they part of the Jones family? I think they'd be part of the Jones family. Last name. Oops. Slash quote. All right. It posted, but it didn't like our null first name and last name. Why did it not like that? Body. We need to. I want to say that. We don't need to require it. Let's try that there. I think that's the annotation we need. Off the top of my head. This is kind of, live coding. What do you get? Okay, let's clear this. There we go. All right, we have Bob Jones, or Fred Jones, and we have Fred Jones again. If we request it on here, there we go. We now have our API we can post and we can get from it. We could, of course, certainly delete from that too. But that's kind of a little bit redundant to show. So in a very small amount of code, we can build a well-structured API endpoint without having to click around on things and have a lot of complexity under the hood. Our dependencies are also not that complicated on the grand scheme of things. You start with, so pom.xml is the whole starting point for a project that you build in Spring. And, oh, that's right. There's a couple other things we should probably do. Is our API healthy? I mean, we saw that it is, but Spring Boot Actuator told us that it is, in fact, healthy. And then, is it Prometheus? Actuator metrics. Hold on here. Let me think of this here, and it will come to me. It's here. Prometheus. Yeah, I know it's there. I just need to find the. Boop, 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 boop. Let's just go to /metrics. I always forget what this one is. Let's set enabled to true, restart. I think it's just /metrics, but there's another way we can get this here. And we can scroll up and it will tell us exposing one endpoint below that. You know what? Let's do the easy way. Spring Boot Prometheus metrics. Okay. I always forget these. URL endpoint. Yep. Yep, you enable them. Endpoints enabled by default. Yeah, there's a security change. True. Let's restart with that. And then I might need to include this here. Yeah. Is that right? Include. Oh, we can just do star. We're gonna make this insecure. Don't do this in production. Star. Okay. I think that's everything. I know I have include by default, but I'm probably being a little bit redundant. Hey, look at that. Okay, we got all the things, actuator / metrics. That's what we wanted here. Metrics, just metrics / they give us the things. This gives us information, and then I could have sworn it was in. Oh, it's just actuator / Prometheus. Okay, so Prometheus is super handy. But there's a certain format here. But what's super cool about this is you can see all kinds of information about the host system, about how in these information is fetched every whatever the collection interval is by your Prometheus server. So it'll hit this endpoint. So you probably want to keep this hidden, but it lets you know how your application is doing. And when that's charted over an extended period of time, you can then observe the health of your application. Maybe you've over provisioned RAM, or maybe under provisioned it, or something like that, or you're hitting CPU congestion, or you have a lot of log error or warning events. All that can be super helpful to understand in terms of sizing and scaling your application. So that's a big advantage that is not exactly easy to do in a PHP application, is understand the health of it outside of understanding like the system as a whole, and then just observing like memory congestion on the server. So a couple of cool things. It's a very quick demo, but whenever I'm building new projects, I'm starting out with Spring Boot for my projects. This is a very quick overview, but I hope you enjoyed that.